Yep, I'd muted myself, but yeah,
We all know each other. Hear him just land.
So, for today, I'm going to do some screen sharing. But what I want to double check is, have people got the little handout that I sent around?
Yes.
Good. Okay, fine. So the little handout will give you a bunch of links and you can kind of follow along on your own machine if you want, whilst trying this out. So what we're going to do today, it's a bit of a double act. I'm going to start off and talk about a little turtle viewer, which I found pretty useful. Other people have as well, and you might too. So I want to give you a quick run through that, and then Boris is going to show how some of the innards of this have been taken and used in a much more powerful way within the Ontology toolkit that we have. So to start off, a screen share. Somewhere I've got the second button to press.
There we go.
Okay. And we'll just follow this document. Let's move it to the side. So here I have something that is based on a browser application that I rustled up a few years back. It started off as being a way of visualizing GraphViz dot diagram code in the browser. It's got on the left-hand side an editor pane, and on the right-hand side some sort of messy menu area, and then a place to draw things. So it started off, as I was saying earlier, with, let me see if I can actually gather this. With the ability to put GraphViz code in, and I just want to show, we'll get one of these diagrams and just paste that in so that you can see how it works with GraphViz. So we just type up some GraphViz there, and in it goes, drawing some stuff. And as you draw, as you type your content, the drawing gets updated. So the rationale here is that we're putting more thought and effort into what our content is on the left-hand side, and we just let the software do the drawing for us. The other thing about it is that a lot of diagrams that people see these days tend to be these force-directed graphs where things are bouncing around the place. One of the benefits that you'll find of this is that nothing bounces anywhere. It's all very static. So when I started to think about how this might work for helping people understand Turtle, all that I needed to do was to put in a triple store in the back end, some means of sorting out the conversion of turtle into dot. And then I wanted to help people start off by picking individual subjects. So here we've got a little illustrative turtle in the left-hand side. And in this menu, we have the IRIs of the subjects. So it's the same sort of thing. If I click one of those, I get the turtle appearing as a graph in the drawing pane, and I can look at different ones. We have blank nodes here represented by orange rings. We have string literals with a blue margin, and we have IRIs with the black margins. I can hold the control key down and select multiple subjects. The other thing which is helpful is that I can click on the boxes here to show in a little box any of the prefixes which are represented in the turtle on the left. I can do another one which omits the RDF type. For some reason, things are very slow today. And the other one, the other little checkbox, is one that enables me to click on object and find the things that are the matching subjects for it. That might not seem too important in something small like this, but when we get a much larger chunk of turtle where an object may be reused across many different subjects, it's kind of interesting and helpful. I can also get different formats of the diagram. So the current version with SVG is an SVG, and that enables you to do panning and zooming. The PNG doesn't allow you to do the panning and zooming, but what it does enable you to do is to right click and then save the image or copy the image. And this is very helpful if you want to use this for creating documentation, putting things into PowerPoints and so on. If you're putting something into a web page, then one of the things that you can also do is to go back to the SVG and click on raw, and that gives you the raw SVG, which you can then copy and stick into a web page. So there's lots of options. And as part of its GraphViz heritage, not only have you got dot, but you've also got Circo and all the other forms of visualizations, Nito and things like that, which are going to be perhaps mince with a lot of the RDF, but you never know, it might be useful. But it's particularly helpful when you're dealing with creating dot diagrams. Now, you can import files by clicking on the Choose button, and we can pick up something. Let me see. I don't know that I really want to bring in any of that, but suffice to say that that's one of the ways in which you can bring in a file. You can also, if you have created some text here, you can also download that, and that just gets downloaded as my file TTL in your downloads. Now, the other way that it can be used is to bring in stuff from the web. Now, if I just pull in this one here, if we have a query string that starts with the dot equals, and then we have an IRI to something that's CORS enabled, then this asks if you want to change the data source, and then it brings that new data source eventually into this left-hand side. And then it populates this with all the subjects. And so what we can then do is to click through them and get the diagram, which we can zoom into. And there's lots of different languages here. So given that this is a GIST meeting, let's go and have a look at GIST using the same approach. And you'll find these links in the handout.
Looks like Doug has his hand up.
Okay.
Hi, Peter.
Hello, Doug. Hi.
Just a quick question. You, when we started, you showed some raw dot files, and they allow you to modify the visual properties of the things, line lengths and color, line thicknesses and color, stuff like that. Is that possible at all when doing this with Turtle?
No, it's not. I've just hard-coded the styles with Turtle.
Okay.
All right.
That's another project for you to work on in the future.
Exactly. That's
Yeah.
right. Yeah.
Good.
Yeah. So
All right.
here what we've got is the same sort of things. For some reason, things are as slow as get out. But here we have GIST classes from it. And what we can do is we can link together, we can see agreement here. So let's just click on that. And we can see how this builds out, okay, from agreement here. And we can follow the way in which the ontology is built.
One of the things I wanted to point it out, if you look at that OWL intersection of, that's actually an RDF list being visualized. So all of that big chain of RDF first and RDF rest links are being collapsed into what looks like a ordered list to make the display a little cleaner.
Okay. Now I'm on the home run, and one of the next things that I want to show is that we can also bring in RDFA into this. So the way that I'll show that is I'm just going to pull the whole URL in, but take this one out. So here is a website which I know has got some RDFA in it. And if instead of using dot, what we use is the query string starting RDFA equals, and put that in, it will go to the site, pull the HTML down, extract the RDFA, put that extracted RDFA into the editor here, and that then enables us to look at the subjects of that. Okay. Finally, sometimes you want to pull something in from resources that give you problems. And one of the ways that I found of getting around that is that I can use this RDFA parser and distiller as an intermediary. And so I can get, I don't know, for some reason, my computer is just being so slow today. I can get something like this, which I hope it works. So here, if I was to take the URL for this web page and put it through the distiller, it will pull out the RDFA. And there's a little bit there. But what I can do, I have difficulty in dealing with this in my viewer. It will hopefully throw an error. Okay, so I've got an error with that, but what I can do is that I can use this intermediary as the source. For some reason, it really has gone to sleep today.
It's not even after 5 in Scotland.
I know.
It's quitting early on you.
It's quitting early. It really is. So I'm not sure why everything is so slow. But
I'll blame the many VPNs you're on.
I think that probably is it.
So Peter, this is just essentially leveraging the distiller directly. Is that the idea?
Yeah, it is. And my point is that you can chain different sorts of things, Michael, in order to bring an extract. Here we go. Extract data in like this. Okay, so we were able to get the RDF from the page and begin to start working with it in this editor. Okay.
Great.
Now, I think that's about it. There are one or two other things that we've got where we can load an IRI from this box. There are also conversions to JSON LD, which is very rough and ready. I'm reversing it back to Turtle, but it's more like N triples. Okay, so maybe I'll pass over to Boris now.
Okay. Let me see. I'm going to grab the share. Let me know when you can see things.
Can do.
All right, super. So one of the things, and this is OntoTool evolved originally as a substitute for a awk script that replaced version numbers when we were releasing gist, because we were pretty OG script hackers here. And it has since expanded greatly in functionality. It can do various transform and RDF exports. It can do batch scripting, which we actually now use in our SemOps continuous integration for gist, both in validating pull requests and managing the releases themselves. And another thing that it has is schema and data visualization. So the origin from this is gist prior to, I believe, version 9.3. Somewhere between version 8 and version 9.3, there was a window of time where gist was partitioned into roughly 15 different sub-ontologies. It was a fair number. And we wanted to be able to visualize the dependencies between those ontologies and which terms lived in each one of the sub-ontologies. So Peter actually originally wrote this visualization tool, again, translating, looking at RDF and translating ontology imports into dot so we can be visualized. So let me see if I have that. So a very basic visualization just looks for ontologies. They can look for ontologies in local files, just specifying somewhere that you have. They can also be run against a Sparkle endpoint and discover the ontologies in the graph. And we have our whimsical Scottish flavor here for a compact display. The flag is -we, because why not? So the basic thing just shows the ontologies and which import which ones. That's the compact display. Now, if we can always generate dot files, but we will also generate PNG if you have GraphViz installed. Or you can use the tool that Peter just showed us to just visualize the dot files and play with that. So you can actually, for the sort of controls, Doug, that you were talking about, you can generate dot diagrams with this, drop them in directly as dot into the other viewer, and play with display criteria. Set colors, line, textures, whatever you want. Now, if you do not go with a compact display, you will get a lot more information in each node. You will get a list of the classes, object properties, data type properties, annotation properties, and any instances that are defined. Now, if you look at this graph over here, and not even zooming in, this big box over here, that's all of gist. And gist has many, many classes and properties. So if you're basing your ontology based on gist and you have it imported, it becomes, it will dominate your graph. Similarly, if you have a taxonomy over here, the taxonomy will define possibly hundreds of terms, and all of them will show up as instances. And again, those will make it difficult to see what you have. So in order to handle that, you can control which ones are specified as compact by just specifying a list of ontology URI patterns. So let's say here I said I want my taxonomy displayed small and I want gist displayed small, and then I just see the rest, which lets me see detail on my individual ontologies, and I can see that the other ones are imported, or in the case of the taxonomy, that they import the other ontologies without them dominating the layout of my graph. And I can zoom in on one of these. So this is for example the same. So here is this is the URI and the simple name of this, or the pref label if it's present. You see the classes, you see the data type properties, and here, object properties, and like here would be data type properties, annotation properties, and instances would show up in these. So you can see, for example, where more of the stuff is populated. And so that is how the things are visualized. Visualizing from a triple store is fairly straightforward as well. You can just say, give it the endpoint of the URI of the endpoint, and it will go and it will discover all the ontologies in there and visualize the dependencies thereof. Now, because of the fact that we don't have, when you do things locally, it assumes that each ontology has a separate file. So you don't need to do anything else to provide which entities are in fact defined in each ontology. You don't have that nice delineation when you go to a triple store. So there are two methods that are supported for partitioning. By default, it will look for RDFS is defined by to figure it out. And as a matter of fact, one of the facilities that are provided by OntoTool as part of its release and export process is you can take a bunch of ontologies and say, export these all together, but set a RDFS is defined by to the original ontology in the process of export. So you can actually keep the partitioning in place. And that's one of the things that we do when we release GIST and some of our customer ontologies as well. The other method that it can look for as a fallback is it says everything in the name graph where the ontology declaration is, which is the triple of X a RDF type OWL ontology. Everything in that name graph belongs to that ontology. And that way you don't have to have the linkages present. It will just partition the graph that way. And then it can group the concepts defined in each ontology with the ontology itself. So that gets us to Schema, and Schema is a kind of a good first set because you can pull out what class definitions you have and what ontologies you have defined. But the more interesting thing when you're looking at a triple store usually is what's in my data. And this is where the instance visualization is it can be very helpful. Same thing, you do OntoTool graphic and you just say data, and the data lives in this triple store. And it will, so the process that it goes through is it will first look for every distinct predicate that is used in that store. It will threshold those because you can specify a minimum of, I think the default is at least 10 instances. If you have things that don't occur very often, you don't really care about them because you're trying to get the general understanding of what the data looks like. But you can control the instances. You can set the noise level like anything greater than 1,000 if you want to get a really kind of only the most used properties. But the idea is because the list of the properties is obtained first, then each one of the predicates is actually sampled separately because we want to be able to set limits. If you have 50 million or 500 million triples in your store, you don't want the triples, the predicates that occur tens of millions of times completely elbowing out the ones that only occur hundreds of times because those may be significant. So it actually runs a separate query per each predicate, and you can set sampling limits and graph filters and various other ways to make sure that you get a meaningful graph in a reasonable amount of time. And you get a visualization that looks like this. So you get every class that is used in the relationships it detects becomes a box. The data type properties that are within that graph. Let's see if I can actually zoom in on this. One moment. Let's see if I can show. So you can see over here, here is a class. It finds out which properties they are, and it actually looks at the data types of the things that are used, and it will tell you what they are. It will pull them out of definitions if it can, or it will actually look at the data and see which types you're using. And then it generates the links over here. Now notice that the links are of different thicknesses. The thicknesses are actually based on the counts of the incidents of the properties as found in the data, subject to sampling limits and such. And it is a logarithmic scale. I think it maxes out at 5 pixels thick, which this is actually a pretty large store. This was a store with roughly, I think, 80 million triples. It took roughly a minute to produce this this diagram out of that store. You can see the things that don't happen very often. This is actually just units, and these occur just a couple of dozen times. So you see it off here and there. It was just imported, and it doesn't happen very often. It was just in some taxonomy. But you can see where the interconnectedness is. And this is one of the things that it identifies. If you have multiple sort of subdomains in your data, because of the fact that it's not quite a forced layout, but it does cluster the things with the heavier links together. So your classes will cluster up in the diagram to show how your instance data divides out. And one of the things that is actually sort of on the to-do list, by the way, Ontology Toolkit is an open GitHub repo, and you can try it, file issues, play with it. One of the things that is to do is to make the nodes size proportional to the incidence of the classes themselves in the triple store, which currently the instance counts don't affect. Only the number, the predicate, the relationship counts do affect rendering. But let's say if the vast thing that dominates is contract doesn't appear any larger than, let's say, ID or person. Whereas, like the biggest thing that would occur at most would be the ID, because there's millions of those in this particular store. So there is a little bit of support for Shackle in here as well. You can turn that on, so it will look for classes for which there is a node shape, and it will look for relationships which are specified via SH path. And you will see those show up as green, as validated relationships, versus the orange ones that are not. So one of the things that this can help you do is, if you are working with Shackle and you are doing validation, you can show that display, and you can actually see which of your classes and relationships have validations and which ones do not. It is still fairly naive as far as detecting it. There's just a few patterns. Like it is nowhere near a full interpretation of the Shackle standard, especially if you have complex alternative paths or things like Sparkle targets as opposed to using target class or target node. It just will not comprehend that yet. So those are future goals. Let's see. Now, the biggest thing where you get is if data if data can get pretty messy if you have a lot of accessory graphs and things like that. So you can refine which data is sampled. So you can either start out with a whole store and exclude specific name graphs, or exclude the graphs by a regular expression pattern, which is the fastest thing, of course, is to exclude specific graphs, a little slower to exclude graphs by this, but more powerful. Or you can start with an empty set and only include specific graphs, which lets you have really fine-grained control for visualizing only a particular portion of your instance data. And you can see over here that particular instances emerged as related instances. You have one kind of a linking class here, and you have this one subdomain and this another subdomain that are related to each other. So that's pretty much the visualization. I mean, I can show the tool running. It's not necessarily incredibly exciting. It's a command line tool that just generates PNG and dot files. Not a full interactive lovely UI like Peter has. But as I said, you can grab. Oh, we just acquired somebody who gave us ethos. David. Okay, better. So yeah, you can export the dot from it and dump it into the dot viewer and play with it, and then decide which parts you want to highlight and so forth. So this has been used only internally, really, so far. Would very much welcome comments, suggestions on what direction you would like this to go. That's all I got.
Nice.
I'll just share.
Thanks,
Great.
Boris.
So yeah, and that's what we're always looking for, sort of interesting visualization tools for RDF. I know that there is so many ways that that these kind of things have been done. We've looked at many many different ways of actually trying to get a meaningful, insightful visualization. I know that, you know, key lines and all of these things exist. So, but I have never found sort of a universal solution, and the idea is to get kind of initial comprehension of data. So I would definitely like to hear kind of what ideas you have. All right, Doug?
Just a question, Boris. So you showed earlier using the graphic option on the command line to point to a triple store, using data
Yes.
and point to a triple store. So that URL, is that like the REST API URL to get to the
It is whatever the Sparkle endpoint is of your
Sparkle endpoint.
Right. Yes.
Okay.
So it right, because it just expects to run queries against it. In this, like for example, in Allegrograph, it is just catalog / whatever repository / whatever the repository ID.
Okay.
For Stardog, it is your Stardog server / the database name / query. It expects to have query on the end. For Neptune, it expects a /Sparkle on the end of the database URI in order to execute the queries. So it's really just whatever is the specific endpoint that works with your database.
That's the query endpoint, right? Not
Yes.
the update endpoint. Yeah.
That is correct. Yes. This particular it doesn't do any updates. The Onto tool will do updates for other stuff. Like for example, it is used to implement our migration queries and lets you specify different endpoints for query versus update in those configurations.
Cool. Thanks.
Yeah, I really like. I kind of had forgotten it was out there. The visual data profiling, because that just seems like something you got to do all the time. And you know, I handwrite that query sometimes each time I go to a new client. Like, okay, wait a minute, I want to see what are my counts from here to here, and but it's much nicer to see a visual view than a tabular view of that.
Yeah, I would emphasize that. I've been wanting this sort of thing for years. It's very handy. Boris, I wondered whether you had something, how easy it would be to do something analogous to what Peter did. In other words, if you have a Sparkle endpoint, you do the same thing.
Oh, are you saying to have it just run in the browser and do the same thing so you can do the visualization more interactive? Yeah, you probably could do that. I mean, currently the tool is written in Python, so it would have to be translated to JavaScript. I don't see why you couldn't do it, certainly. Python makes some things easier, but that's just
it may be very, very slow. I don't know if it would be.
The vast majority of the time is spent actually just running the queries. The post-processing is not that thing. By the way, I just wanted to show one more thing as a, you know, kind of early attempts to do data visualization. I have a thing in progress that is based on D3, and it's actually a 3D graph of ontology visualization, and you can zoom in and look for the same thing. Line thicknesses are this to really emphasize the clustering of information. This one shows kind of an extreme partitioning between two domains. But this one, it's very difficult to, and I know the panning and the zooming probably looks really terrible on Teams. It does give you some insights. I've used it previously when I really don't know a store to really see how the stuff partitions, but it's not. Overall, it didn't have this. This tool didn't have the sort of precise control that the other one did. But this is completely running in the browser. This is just D3 going off of data.
Very cool.
Michael, you're muted.
I don't have any more questions. I'm gonna.
Okay, just still have the hand up. All right.
So, Mark, you have practical consulting use of these tools, don't you? Not the Ontitool one, but the other one.
The what I call the turtle viewer, which is really a dot viewer.
The turtle viewer.
Absolutely. I used it today. In fact, we had an internal discussion. I won't get into it a lot, but it talks about the idea of Agile semantic knowledge graph development, right? What if you're on an Agile team and you can't just work on Ontology for 3 months? And I've found this to be a super useful tool to mock up RDF, what I call RDF exemplars. So, which I would tend to do in Turtle a lot of times anyway. But the nice thing is you can use it to build up an example shape, if you will, right? Even just while you're thinking, you're in the ideation stage and you're saying, well, okay, there's already these classes we already have in our enterprise ontology, and we probably need some new ones. And I build an exemplar, and what's nice is, like Peter said, I go straight to the PNG version. I'll save it, and essentially I can save off my turtle and a picture and give it to, let's say, the API team. And just people who want to understand. So it's kind of like what we call a party or a visual design. Here's what we think this is going to look like. The nice thing is you got the turtle because you actually use that to create the visual design. So you can not only save that off, but I've found you can put that directly into a triple store before you've really done any ETL, right? You just spitball the data, you throw it in there, and the API team can already start using what the latest candidate shape is. So I've just found that it's very easy to communicate, and at least at the client I'm at, they've all jumped on board. At this point, I can just send them a turtle file and they'll throw it in the tool and they'll look at it and everything. So for rapid prototyping of graph structures and rapid visualization, it's been really good.
I've also used it for documentation. The number of times that I've come across documentation of ontologies to find that the examples of turtle that are given don't actually parse, something is missing. And this absolutely ensures that you've got a parsable, a proper chunk of RDF that you can guarantee is going to be complete.
Absolutely. I find that all the time. In fact, it keeps me honest on that. I literally, while we're on this session in the background, I'm using it with on a client to build. And the nice thing is you can also just with that you can, like with the SVG, I'll do a quick screen grab and snapshot. I'll paste it into Jira tickets. So we have a whole team that's trying to build something, and we're just the ontology and knowledge graph part. So again, for very quick, here's some data, here's a picture. It's just super fast for that. It's been great.
So what I would like to be able to do is to work with GitHub at the back end. So if anybody can help me with that, that would be really, really good.
Look at a set of data or an ontology that's already sitting in GitHub and just pull it and visualize it. Yeah, nice.
Pull it in, and then to make changes, and then to commit.
Check back in.
That's what I'm really wanting, is to be able to round trip it that sort of way.
Nice.
So any help? Anybody knows how I can do?
You're on mute.
Thank you. To emphasize what Mark was saying, how easy it is and how fast it is to generate a quick little model. And we use this to show to the client. So it's even just maybe you're modeling out some particularly challenging thing with a bunch of interconnections. They just manually code up maybe 20 or 50 triples. And you just want to show what that looks like. It will take an hour or two messing around in the diagramming tool, and this just happens automatically. But I just wanted to show, if I could share my screen for a moment, the power of that filtering stuff that Boris showed us a few minutes ago. So that was a real example. You can see my screen now. This is we generated this from a triple store, and this is completely useless, really, if you think about it. And what is all this stuff? Who knows? Turns out the part that we really care about is down here at the bottom, up here at the top. And these were, all this extra stuff was kind of inferred triples that we put in there for various reasons to do cool stuff. But what we really wanted was what Boris told us. And so all we did was we filtered on some of the names of the properties and the name graphs, and we got this. So I just wanted to show how powerful that is. And with that, I will release.
Yeah, because in that particular database, I believe it was about 1.5 million triples, and the total generation time was less than 30 seconds. So it was pretty quick.
I guess I don't know if this is super relevant, but I mean, you need to have the tool local or the triple store local, right? Have you had confirm that for me, and then have you had any trouble where they just won't let you bring it in because it's open source?
I mean, it's a Python package. I've used it locally, but yes, I've run into this with a client. I have a client that actually has their triple store. It's a EDG that sits behind a firewall using SAML authentication, and yes, I can't do anything with it. You do need to have it accessible. You have to be able to either bring in the tool behind the firewall or have something as accessible. Using other authentication, because right now it really just uses simple basic authentication to access the endpoints, which is great in a development environment, not so great if you want to play around with a production triple store. So being able to use like SSO or Kerberos authentication or something like that is a future goal. It just hasn't been a priority so far. But yes, having the visualization tool run in browser works around this problem because it lets the browser authenticate for you, and so perhaps the idea that Michael was suggesting of just porting that code into to run in JavaScript, perhaps just become another module in Peter's tool to say just instead of loading a data file or loading scraping RDFA, hit this triple store and generate the visualization and use the same visualization tool.
Well, one of the things that's worth saying is that this is only really possible in the browser one because of the RDF.js libraries that are available now. And they're very, very good. They're extremely performant when it comes to streamed parsing, which is what that uses, and the data store. And programming that browser side is really, well, I can do it, so it must be fairly easy.
All right, so we have 5 minutes remaining, I guess, if we want to bring up any last questions or directions, ideas, share similar experiences.
Yeah, does anyone else have a similar tool or approach that we should be considering? I mean, we're always looking for these things.
I guess we're blazing the trail.
Yeah, I guess.
I know that Adrian Geschwend and colleagues have got some things which will do similar and return kind of a little bit like UML class diagram details. And again, it's like, how do you introspect triple store and work out what's there and how it's related? So, I think that there are a small number of these tools around that are all based on the same sort of approach, the RDF, JS, Communica, things like that.
Saibo, Dean Alamang mostly developed a whole bunch of tools. He developed a toolkit that included a whole bunch of different things that's used for FIBO. I think that's probably publicly aware, but I haven't dived into it. Has anybody looked into that package at all?
Oh, I see a question in the chat asking if slow reveal is related to this particular Python tool. No, it is not, and slow reveal to some extent is a scripted exposure, and it does run in the browser. And this one was meant to be just a part of a static pipeline. So it's supposed to give you all the data as opposed to a sort of a scripted presentation. So while both of them can be, one is an analysis tool and the other one is guided exploration, as it were.
Right.
But there is some crossover between the two, and certainly a possible future direction for integration.
Okay. Well, let's call it a wrap then. Thanks, guys. That's very good.
Thanks, everyone.
Yeah. Thanks for making your work available.